Hello, today we're going to talk about anti-differentiation and indefinite integrals. So basically what it means is we're going to do the exact opposite of differentiation. We're going to do reverse differentiation. Now let's look at an example and maybe we'll be able to understand better. So we have 4x squared plus 3x plus 4 dx. Now in order to be able to solve it, an easier way to do it is, so we have 4x squared, we're gonna write x, and we know that in order to derive, we're gonna take the power and decrease it by 1. But since we're doing anti-differentiation, we're doing the exact same, the opposite. So we're gonna do 2 plus 1. So x to the power of 3, basically. Let's write down 3. And now we need to multiply something by 3 in order to get 4. So an easy way to remember is taking the number that we had before, 4, and over the new power, so 3. Now 3x is going to become, we have x, so it's x to the power of 1, so it's going to be x squared. And now we're going to take the number that we had before, so we had 3, I'm going to put 3 down, and the new power that we have is 2, so it's 3 over 2, plus 4, so it's going to become 4 dx, and we always going to put c at the end in case we just said a regular number like 20 or 40 or 1000 or 1, it just disappeared because it didn't have an x next to it. Alright, that was example number 1. Example number 2, we're gonna have 2x to the power of 4 plus 6x to the power of 3 plus 40x dx. Now let's try what we did before. We have x to the power of 4, which is, we're gonna do 4 plus 1, gonna give us 5. And now we have 2 here, so I'm gonna write 2 here, divide by the new power that we got, which is 5, so it's 2 over 5, x to the power of 5, plus, I'm gonna write x down, x to the power of 3, 3 plus 1 is 4, so x to the power of 4. Now we're gonna write down the number that we had before, so 6 over the new power, 6 over 4, x to the power of 4, plus, we have x to the power of 1, so it's x squared. Now, here we need to be a little bit creative, so 2 multiplied by what to get 40, it's gonna be 20, right? So 20x squared plus c. Now, the best thing about anti-differentiation is we can always check if our answer is right. Okay, so now let's derive that. Y prime 5 multiplied by 2/5 x to the power of 5 minus 1 plus 4 multiplied by 3/2 x to the power of 4 minus 1 plus 2 multiplied by 20 x to the power of 2 minus 1. C disappears since C is a number that we don't know if it existed or no, it disappears. So y equals 5 multiplied by 2/5 is 10/5, which is 2, so 2x to the power of 4 plus 4 multiplied by 3/2 is 12 over 2, so it's gonna be 6x to the power of 3 plus 2 multiplied by 20 is 40, 2 minus 1 is 1, so 40x, and that is the answer. So we can see how this is equals to this. So every time we anti-differentiate and we get an answer, we can always derive it and see if we got the same result. Now let's have another problem. 3 plus y to the power of 3 minus y to the power of 2/7 dy. Okay, so let's solve it. We have 3, which is going to become 3y, plus we have y to the power of 4. And now we're going to write down the y that we have here. So it's 1y, so it's going to be 1 over the new power, which is 4. So it's 1/4 x to the power of 4. And now we're going to have y. Then we're going to have 2/7 plus 1 equals 9/7. So it's going to be y 9 to the power of 9/7. So now in order to get to 1, we're just going to flip it. So it's going to be 7/9. So there is plus c at the end. So the result is going to be 3y plus 1/4 x to the power of 4 minus 7/9 y to the power of 9/7 plus c. Now let's derive that. So let's write 3y, y equals 3y plus 1/4 y to the power of 4 minus 7/9 y to the power of 9/7. If we're deriving that, we're going to be left with 3 plus 4 multiplied by 1/4 y to the power of 4 minus 1 minus 9/7 multiplied by 7/9 to the power of y, 9/7 minus 7/7. So y prime would be 3 plus 4 multiplied by 1/4 is 1, so we're going to be left with y to the power of 3, because we have 4 minus 1 here, minus 9/7 multiplied by 7/9 is 1, so we're going to be left with y, and then to the power of 9/7 minus 7/7, 2/7, so we can see how that equals that, so we know that the answer is right. Let's look at another example. We have 3. We're gonna have x to the power of minus 3 plus x to the power of 3 minus 2x to the power of minus 2 plus 3x to the power of minus 1. Now I just want to write down on the side that x to the power of minus 1 equals 1 over x. And ln x, when we derive ln x, it's 1 over x. Now we're going to see why it's important. So equals, we have x. So we know that we need to add 1 to minus 3. A common mistake would be to write minus 4. But 3 minus 1 equals minus 4. Minus 3 minus 1 equals minus 4. And minus 3 plus 1 equals minus 2. So we have 1 here, we have a 2 here. So it's going to be 1 half x to the power of minus 2 plus x, and now we have 3 plus 1, which is 4. So we're going to have 1/4 from the 1 here, and the 4 comes here. Then we have minus here and minus here. So before we're going to write minus or plus, we're just going to write down x. Minus 2 plus 1 is going to be minus 1. Now in order to get a 2, we know that we need to have a 2 here, because 1 multiplied by 2 is equals 2. But since we're going to multiply by minus 1, and we need a minus here, so we're gonna change it to plus. So it's very important to make sure that we don't make this mistake. And now we have plus 3, but we have x to the power of minus 1, which is that. That's why we wrote it down. So in order to derive 1 over x dx, the result is going to be ln x. So we're going to have 3 ln x plus c.